Hello everyone. Today let's start with the Nyquist theorem and then proceed with the types of transmission media. So what actually is Nyquist theorem? It is used to check another important property in a network, like it allows to calculate the maximum data a channel can hold. So we need to break a given signal into frequency components and see the highest frequency a channel can take to transmit. So it is usually calculated. It is usually calculated with this formula 2b, where b is the bandwidth. So considering human voice, as I have mentioned in the earlier video, it's 3000 hertz. The frequency of a human voice is 3000 hertz. So there should be a medium of 6000 hertz or more for human voice to transfer. Heading on to the transmission media. So transmission media is divided into two types. The first one is the guided transmission media. It is where you have a medium like the channel or the cable, and the other one is like air. So in the guided transmission media, we have all these types, and let us discuss them one by one. This is called guided transmission media because we can control the direction of the signal, and it is done with any conductor that can be present in the cable. First one is the magnetic media. Um, so magnetic media is like when you use magnets to transfer signal, like the tapes and discs. Twisted pairs. So just twisted pairs, they use category 5 cable, that's the cat5 cable, and UTP is the untunic twisted pair. We see that there are there are two pairs of cables that are twisted, and they are acting as a single cable. So it is done in order to prevent them from acting like an antenna. So if it's just a single cable, uh, it'll be taken as an antenna, and any signal nearby uh, can affect it. So two pairs of cables are twisted in order to send the signals. The next one is the coaxial cable. We mostly find these kind of cables in the TVs or the television, the internet, at our home. So it is called the coaxial cable because it has two types of conductors. One conductor, this is the inner conductor. This one conductor stays in the middle, and the other conductor encapsulates it. This is the outer conductor, and this is the covering of a cable, the insulator. There is an insulator between the two conductors as well. This is that one. The next one is the power lines. I think most of us usually see it at our homes. So these are the lines we use at homes to connect our devices. This is the cable, and there is an internal connection between the switch ports. So the problem with these power lines is that there's when we have a power outage or voltage issues, it can easily affect our devices. So it's not that preferable to use them. fiber optics, like most of the cables nowadays are fiber optics. It is similar to coaxial. Here, uh, I know most of you know that light has a reflecting property. So when light is thrown on any prism or mirror, it reflects into different directions. The same formula is used by fiber optics, but in a different way. So fiber optics use total internal reflection. When light is thrown on a prism, it reflects into different directions like this, and sometimes inside with any angle. But in fiber optics, uh, when light is thrown, I mean, when the signal is thrown, it goes inside, reflects inside the cable, keeps on reflecting, and this happens just inside the cable. So it can go to long distances.